Hi everybody. In this chapter we want to have a closer look at the properties of the electric circuit. So let's draw the circuit again. I have added an ammeter again, and we want to discuss what does the current depend on. One possibility is I replace the battery. For example, I have a weak one and then I take a stronger one. The strength of the battery will not be given in newtons, of course, so it will be another physical unit we will encounter. It is the so-called voltage or the electric potential difference. The abbreviation for it is the capital letter V, which declares the strength, so to say, of the battery. What is left in our circuit? The ammeter is just to measure the current, so we have the idea that the influence should be near to zero. The only thing left, therefore, is the light bulb. And the type of light bulb determines as well how much current is flowing. Of course, it hasn't to be a light bulb necessarily, so it could be any type of machine or electric consumer that we have here. We could also talk about the strength of a light bulb, but here the technical term is the resistance of a light bulb. The resistance is abbreviated with the capital letter R. In the next two chapters, we will have a closer look to the voltage V and the resistance R. Let's start with the voltage. Let's start with an experiment. We have an electric circuit. My hand is on the knob changing the voltage, and we can measure on the instrument left on the ammeter the current that flows. We have seen the bigger the voltage applied, the larger the current that is flowing through the bulb. So I is proportional to V. But what is voltage really? If we look again at the electric circuit, the job of the battery is to pump around electrons. And we do not want to have these electrons for the sake of electrons. We want to have energy. So the electric current transports energy, and this energy comes out of the battery. In reality, it is electrons that the battery is pumping around, but attached to these electrons is a certain energy, and the voltage is nothing but the energy that the electrons have. So let's try to define that properly. You might have heard of a battery, for example a 4.5 volt battery. This voltage is always given. So what is 4.5 volts? 4.5 volts just tells us that 4.5 joules of energy is transported, not on each electron, but if we have 1 coulomb of electrons flowing around. If 1 coulomb of electrons transport, for example, 4.5 joules, then the battery has a voltage of 4.5 joules per coulomb, which we call volts. If the battery has 12 volts, it transfers 12 joules per coulomb or 24 joules per coulomb or whatever number. So the more voltage it is, the more energetic the electrons are. Let's write this down as a definition. The symbol for voltage, as mentioned, is the capital letter V, and it is the electrical energy or the electrical work done per charge. The unit, therefore, is joules per coulomb, which we call a volt. Careful, V can just be volt, so it can be the unit of it, but V is also the symbol for the voltage, so it's twice the same letter. In German, this is a little bit better. In German books, this is referred to with the capital letter U.